Something that is impossible to do with only a compass and a straight edge is to trisect an angle using just compass and straight edge. However, using paper folding and especially using axiom number 6, it is possible to trisect an angle. I'll show you how to do that. Over here we have our angle that we want to trisect. And the first step is to make a fold onto any point, fold B onto this point E, and make this parallel line here. And then fold, when you fold B onto E, you make this, you get this parallel line there. But then, if through E you make another fold, or just use a straight edge at that point, you can make these two lines. So the main thing here is that this segment is congruent to that segment. Now comes the very important fold. We want to make a single fold that will put this E somewhere onto this line. While simultaneously putting this B point onto this line over here. That's the goal. Axiom 6 in paper folding says that it's possible, if I have 2 points and 2 lines, to make a fold that puts 1 point onto one of the lines and another point onto another line. So it's possible to make that fold, or when it is possible, you are permitted to do it. So we do it, and we end up with the fold down here. There's the fold. Now, if we keep it folded, so B ended up over here, and E ended up over here. But this point D moved also. So if you mark off where that point D ends up over here, that's going to be very important. If we come over to this picture, we could see it a little bit better. So here on the left is the fold that's made. A couple of things I want you to notice. This piece, this segment and this segment are definitely congruent, because if you remember, before this thing was folded, those were made, all 4 of these line segments are the same length. So that makes this and this also those lengths, because this length and this length were the same as this length and this length before the fold, and this length here is the same length also. So when I go over here for the unfolding, and remember I marked off where point D ended up, it turns out that if you connect D1, the place where D ended up, to B, that this angle will be exactly 1/3 of the original angle. And the reason this is, it has to do with congruent triangles. So these two triangles are congruent, because remember, this length and this length were equal, because those were these two things before the fold. Here we have the right angles, and we have this shared side. So these two triangles are definitely congruent. On the other hand, if I look over here, I have this third triangle. This has this length in it. It has this shared side. And because these are right triangles, we have the hypotenuse leg theorem, says that these two triangles are congruent. So all 3 triangles are congruent, makes all 3 of these angles congruent, makes this one 1/3 of the original, or what that fold accomplished. Again, when I made the fold, and the place where D ended up in making the fold, that connected with B accomplished the trisection of the angle. At least this piece is 1/3 of the original.